Okay, we're going to go over how to solve the 4 practice problems from the PowerPoint. We understand that you probably have solved density problems in the past before. That's fantastic. Hopefully this is a review. But remember, the point is not to just solve the density problems using the equation, but solve them using unit analysis. So we're not worried about rearranging equations so much as eliminating units so that we don't need, so that we end up with the one that we do. So if this looks a little bit different, that's okay. We want you to learn this process now before you need it later. So number 1, mercury metal is poured into a graduated cylinder that holds 22.5 grams per milliliter, or sorry, just 22.5 milliliters. The mercury weighs 306 grams. What is the density? So this is an easy one because we know that density is just mass over volume, and we have those two pieces already. So 306.0 grams over 22.5 milliliters. You've got to think about significant figures. This one has 4, this one has 3. We're doing division, so we get to keep 3 sig figs. So this would end up being 13.6 grams per milliliter. Note that grams stays in the numerator and millimeters remains in the denominator. Okay, so that's that. Number 2, a rectangular block of copper weighs 1,896 grams. The dimensions are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. Once again, we're looking for density. The only difference between this problem and the previous one is that volume is not explicitly given, but we can find it by taking, let's say the 8.4 is the length, the width, the height, multiply those all against each other, you get the volume. So 8.4 centimeters times 5.5 centimeters times 4.6 centimeters. Now you do not need to do this calculation ahead of time. Just make sure that you are putting this bottom piece in parentheses. And then your unit down here will end up being centimeters cubed. Your mass, of course, is 1,896. All right, you only get to keep 2 significant figures because of these guys down here. So this would end up being 8.9 grams per centimeter cubed. Okay. When we're solving just straight density problems, it's pretty easy. You make sure that you have grams and milliliters or centimeters cubed. Where it gets a little bit more interesting is when you're solving for something that is not density. So for instance, what is the mass of ethyl alcohol that fills a 200 milliliter container? And that tells you that the density is 0.789 grams per milliliter. So if you are a visual person, you can write down all of your variables like this and get organized. What is the mass means that's a big old question mark. 200 milliliter container. And then the density, so 200 milliliters, that's our volume. The density is 0.789 grams per milliliter. And of course, we know that the invisible number in front of milliliter is 1. All right, and that's important because for every 1 milliliter of ethyl alcohol, that 1 milliliter will have a mass of 0.789 grams. When you are doing these problems, I think the best thing that you can do for yourself is have in mind the unit that you want to end up with when you are all done. If we are looking for mass, then the only unit that I want to have is grams. Okay, which means I need to get rid of everything else that isn't grams. So I'm going to start with my volume, which is 200 milliliters. Okay, and that's effectively just a fraction over 1. 200 milliliters is in the numerator. And I'm going to use my density as a conversion factor, where the goal is to get rid of milliliters and be left with grams. Now, in order for a unit to cancel, it needs to appear in both the numerator and the denominator. Just like 4 divided by 4 is 1, and x over x is 1, milliliters divided by milliliters is also 1. That's what's going to help it, or make it rather, cancel. So if I have milliliters in the numerator here, that means I need to have milliliters in the denominator down here so that that unit will cancel. So for every, according to my density, 1 milliliter of ethyl alcohol, that will have a mass of 0.789 grams. Okay, so I'm not paying attention to an equation. I'm not even plugging things into my calculator quite yet. I am just worried about, do my units cancel and do I end up with the thing that I want? Well, I set this up such that milliliters would cancel, And that does leave me with grams in the numerator, which is perfect because that is what I am looking for. Now I just need to be careful with how I plug this into my calculator. If you have a number in the numerator, you multiply. If it's in the denominator, you divide. So this time we're going to multiply 200 times 0.789 grams with sig figs is going to give us, oh yeah, there we go. We get to keep 3 sig figs. So that's going to give us 158 grams. Okay, so that was solving for mass. We can do one more where we solve for volume this time. Okay. So this one says find the volume. In fact, I'm just going to write that down. Find the volume. There's my question mark of 219.2 grams. There's my mass of benzene, which has a density of 0.8765 grams per milliliter. Benzene's a really cool molecule. The formula is C6H6. If we were to draw it with the organic shorthand, looks like that. It's a very non-polar organic solvent. They used to use it as a carpet cleaner, and then they realized that it was giving people cancer, so they stopped doing that. Thank goodness. It still has other uses, just not in carpet cleaning. So this time we are solving for volume. We measure volume in milliliters. So when I'm all done, I want to have milliliters be my only unit left. I know that this benzene has a mass of 219.2 grams. That's a unit I want to cancel out. I want that gone. All right, I can use my density to make that happen. So for every 1 milliliter of benzene, okay, if I took 1 milliliter of benzene and put it on a balance, it would have a mass of 0.8765 grams. I'm going to use that 0.8765 grams to cancel out grams here, which will leave me with milliliters. Okay, this time, when I put this in my calculator, 219.2, this is over 1. If you really want to, 219.2 divided by 1 times 1, even though that won't make a difference, but then effectively, or importantly, divide by 0.8765 grams. All right, this time I get to keep 4 significant figures, and that would end up being 250.1 milliliters. And that would be your final answer.